Hello everyone, I'm Yuri Kimura. I'm so glad to meet you today. I'm working for research and development of STEM education. Co-author Rumi Haraguchi is my colleague and Tadashi Otani is professor at Tokyo Gakuei University. Technology education is one of his specialties. Today, I would like to talk about the theoretical framework of science learning materials for Japanese elementary school STEM education. First, I'd like to introduce you to our organization and the learning materials we developed. Then, I will show you the purpose and the range of this study. We started our STEM educational project in 2013 as an industrial academic collaboration project to promote STEM education in Japan. We researched and developed the organized STEM education for school and social education and playgrounds. Members are researchers, representative of affiliated company, and teachers of primary and middle schools. One of the practices promoted in the project is the development of learning materials for STEM education. Mirai series is one of them, specialized for school education, conforming to Japanese curriculum. Today, I will focus on Science Mirai or Mirai series intended for science lessons for Japanese elementary school. Science Mirai consists of a control box with Arduino for programming, Gigo blocks including motors and sensors, a lesson plan conformed to Japanese curriculum, and the worksheet. The lesson plan incorporating engineering activities into science lessons. However, it was not studied how to introduce engineering into Japanese science lessons. So we think it necessary to examine the theoretical framework. Next, I'd like to discuss the theoretical framework of STEM education for introducing engineering, focusing on Science Mirai, a science learning material adapting the engineering activities. Now, I will explain why we put engineering activities in Science Mirai. In the background, there is a problem of Japanese science education that the student interest in science are declining. Thus, the relevance of science education and society and everyday life is emphasized in Japanese national curriculum guideline, aiming at raising student interest in learning through realizing how significant and useful science learning is. Since it's perceived as a problem in Japan that the students have a significantly lower interest in science than those in other countries. On the other hand, the training of innovators who could solve an experienced problem in society and everyday life was anticipated in the fifth Science and Technology Basic Plan by the Japanese cabinet in 2016. So we decided to incorporate the context of problem solving in society and everyday life into science lessons and adapt engineering activities. According to those background, we examined the theoretical framework for introducing engineering activities in this study. As you know, there are various perspectives regarding the integration of STEM education. In our project, STEM education is considered as shown in this figure. It's an image of three-legged chair. We think engineering is the center of STEM education and propped by the three legs: science, technology, and mathematics. Engineering is a creative activity. Science, technology, and mathematics are exploratory activities, which means their processes are different. We aimed to design learning in which students go back and forth between creative and exploratory activities to solve social problems. In order to realize such STEM education in Japanese schools, we have developed Science Mirai. When we try to incorporate engineering activities in science education, we've met a challenge. How could students go back and forth between two types of activities? Previous studies have examined some theoretical frameworks for STEM education. Among them, we focused on learning model called Learning by Design, proposed by Cordula. The Learning by Design learning cycle consists of different two cycles: design, redesign, and investigation, and they are bridged by need to do and need to know. Investigation has been conducted as a result of need to know in the context of knowing how the things students learned could be used. As I mentioned earlier, we aimed to incorporate engineering creative process in science education exploratory processes. In that sense, learning by design fit to this study. Moreover, Yata et al. Showed that based on Japanese subject principles, relevance to each STEM discipline was found in the engineering process. So we considered that learning by design is effective for motivating Japanese students in science learning and choose it as the base of the theoretical framework of this study. Based on learning by design, we examined the theoretical framework most suitable for this study. It's presented here as adjusted learning by design. While original learning by design is a very good learning model, we found that there is a challenge in adapting learning by design directly into Japanese elementary school science lessons. If learning by design is introduced as it is, while complying with Japanese curriculum guidelines, time would be insufficient. Thus, in this study, we adjusted learning by design to practice it in limited time by reducing and simplify the activities in each stage of engineering process by giving the scaffoldings. Now I will talk about Science Mirai developed based on this adjusted learning by design. First, I will focus on the three key points in developing Science Mirai. First, selection of the learning contents. As you can imagine, some science learning contents may easily adapt engineering activities while others may not. Thus, we selected content of electromagnets that the engineering activities easily adapted. Second, adapting the context of problem solving of society and everyday life, we chose improving garbage and resources problem as the main context and set the situation of separation of steel and aluminum cans for recycling. Students could create the lifting magnets and tackle the issue of efficient separation. The last but not the least is devising how to introduce engineering while keeping the science learning contents. The main purpose of the lesson is to study science, not the engineering activity itself. So we tried to simplify the engineering activities by reducing the cost of initial design and trial production. For example, students would try the first challenge with the building procedure manual of the prototype machine. This is the lesson plan. The main part of Science Mirror has three steps. Challenge 1 is to separate steel and aluminum cans for recycling. Challenge 2 is to do it more efficiently. Challenge 3 is to do it automatically. Let's look at the student learning process when tackling challenge 2. This is a learning plan applied in the adjusted learning by design to show how the back and forth of learning process occurs. We designed a lesson plan in which need to know occurs at second stage of design redesign process and switch to science exploratory activity. Students would use the result of science exploratory activities for challenge 2. Here is the conclusion. This study considers the theoretical framework for science learning material incorporating engineering activities in elementary school STEM education. As a result, the important points of the theoretical framework were clarified. To simplify engineering activity by introducing scaffolding for keeping the learning contents of science. In addition, results of test practice showed the learning plan of science Mirai based on the theoretical framework enabled students to learn science in context of problem solving in society and everyday life triggered by engineering activities. Moreover, the result also showed that science lessons that adapted engineering has raised student awareness of science practically. Thank you for your attention.